Good morning, students. So we are continuing with the wave optics topic. So in the wave optics, today we are discussing that is the refraction phenomena, the derivation part we have seen in the last class. So today we are discussing, or today we are showing a diagram which is representing the refraction of a plane wave at a rarer medium. Okay, so here diagram is there which may come for the 2 mark. Okay, so I'll share it 1 second. Yes, the screen is visible. See, now it is visible. Okay. So in the last class, we have applied the Huygens principle. So Huygens principle already we have discussed. So we applied the Huygens principle for the that is reflection phenomena. So reflection, that is the laws of reflection we have proved by using this, and laws of refraction also we have proved. So in the laws of refraction, we used that is the triangle, that is trigonometric help we have taken. With that we have proved sin I by sin r is equal to n2 divided by n1 ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ. ಸೊ ಈಗ ನಾವೇನ್ ಮಾಡೋಣ ಅಂತ ಅಂದ್ರೆ we will go for the next part. So in the next part what we are seeing is that is the diagram which is representing the refraction of a plane. For that we are considering one medium. It is a denser medium. Okay, so this is a denser medium, inside is a denser medium and outside is a rarer medium. Idu rarer medium agate, idu ಒಳಗಡೆದು denser medium agate. So here A dash A, we are considering the rays now. So this is incident wavefront and this is again one more incident wavefront. So this is A and here it is A dash, and next here we have B. This is also A and B are the incident wavefront. Okay, AB are the incident wavefront. Here only diagram is important, trust it. So this is point C. So whatever, this is point B. Here whatever the distance is there, this is nothing but it is VT. Then next, this is E. Okay, so here whatever this surface is there, we will name it as Mn. This is M, this is N. This Mn is a refracting surface. Mn is a refracting surface. A dash A. So here we can see A dash A. I'll change the color so that you can see. So illane A dash A ಕಾಣಿಸ್ತಾ ಇದೆ. This is incident ray. Okay, so this is incident ray. ಮತ್ತೆ ಇಲ್ಲೇನ್ BC ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is also the incident ray. Here AE what you are observing. So total. Okay, so ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ. So here whatever you are seeing, this AE is the refracted ray. AE is the refracted ray. Yes, and here we can show the normal for this surface, and this is taken as angle of incidence, and here we can take it as what? Angle of refraction. Angle of incidence and angle of refraction. And then next, this is also angle of incidence, and here this is also angle of refraction. This one is angle of refraction. Okay, so just this is draw a diagram which shows the refraction of a plane wave at a rarer medium. The refraction at a plane wave for the rarer medium. Okay, so just you have to show this is a refracting surface, denser medium, rarer medium, incident ray, the refracted ray, angles. Here the thing is what refraction andre enu, the ray will change the direction. So nim diagram ಯಾವ ತರ ಇರಬೇಕಂತ ಅಂದ್ರೆ incident ray ಏನಿರುತ್ತೆ, so ಇದು ಯಾವಾಗ ರಿಫ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ, it should go away from the normal. ಆ ತರ diagram ನೀಟ್ ಆಗಿ ಬರಬೇಕು ಆಯ್ತಾ. Okay, so in the notes part I'll give you the proper diagram so that you can refer it for your exam. Okay, students, let's go for the next point. So this reflection, refraction, we have discussed already. We have proved the refraction using the Huygens principle. So this is also completed. Yes. Now, what do you mean by the coherent and the incoherent sources? See. So see here the coherent sources we are discussing. What is coherent sources? The two sources of light which continuously emit light waves of the same frequency with zero or constant phase difference between them are called as what? Coherent sources ಅಂತ ಹೇಳ್ತಾರೆ. So many times in the light chapters ಅಲ್ಲಿ ನಾವು ಏನಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ? Coherent and the incoherent sources ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So what do you mean by the coherent sources? The coherent sources nothing but ಅದ್ರದ್ದು ಏನ್ characteristics ಇರಬೇಕು ಅಂತಂದ್ರೆ it should have the same frequency. It should have the same frequency must be there, or you can also say it as it must be of the same wavelength with zero or constant phase difference. With zero or the constant phase difference is called as what? That is the coherent sources. Okay, so coherent source anta helbekadre adike ಏನು characteristics ಇರಬೇಕು? Either they should have the same frequency or the same wavelength, and it should have the zero or the constant phase differences. So those type of sources are called as what? Okay. Then what will be the incoherent sources? The incoherent sources do not emit light waves with a constant phase difference. So coherent sources ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? Constant phase difference ಇರುತ್ತೆ. In case of the incoherent sources, the phase difference is not constant. So it is not a constant one. So those are called as what? Incoherent sources. Okay, so in case incoherent sources, the light waves are having different intensities like I1 and I2. So different intensity irutte I1 ಮತ್ತೆ I2 ಅಂತ. ಹಾಗಾದ್ರೆ resultant intensity of these lights ಯಾವ ರೀತಿಯಾಗಿ find out ಮಾಡಬಹುದು? So for example, if you consider the source ಇದೆ ಅಂತ, okay, so this is a incoherent source. So incoherent source ಇರಬೇಕಾದ್ರೆ this wave is having different intensity and this wave is having different intensity. So this is having intensity I1 and this is having intensity I2. ಹಾಗಾದ್ರೆ ಎರಡರದ್ದು resultant intensity ಬರುತ್ತೆ. So the idea of finding out here. So what is the resultant intensity of these two waves that we need to understand? So for that reason, here we have the formula, derivation in the direct formula. The intensity of the light is given by I is equal to I1 plus I2 plus 2 under root of I1 into I2 into cos of. Here you can see. So here we have the formula to find out the resultant intensity of the incoherent sources. Yes. So this is the formula. Please remember the formula, which will help, especially in the competitive part. Regular board syllabus numericals and barala. Just in the competitive exams, these formulas are important. So formula. Yes. So coherent sources, incoherent sources. Is it clear, everyone? So here, if you want to explain again regarding the incoherent sources, so see, the sources have different frequencies. So coherent sources alli enirutte, they are having the same frequencies. Incoherent sources, they are having the different frequencies. The source have the same frequency but no stable phase difference. So ಕೆಲವೊಂದ್ಸಲಿ frequency same ಇದ್ರೂ ಕೂಡ phase difference constant ಇರಲ್ಲ. So that is also the characteristics of the incoherent sources. And for such a coherent sources, so coherent source ಇದ್ದಾಗ ಅದರ resultant intensity, that is I1 plus I2 ಅಂತ just now find out ಮಾಡಬಹುದು. If it is a incoherent sources, we can use this formula. Yes. Okay. So now we are going for the next point. So see, in the electrostatics, you have studied about the superposition principles, right, students? So what is superposition principle? In the superposition principle, what you will study? So charges will study ಮಾಡ್ತೀವಿ. So according to the Coulomb's law, the forces given by Okay, so here, what is that superposition principle? According to the superposition principle, suppose here one charge is there, this is Q1 charge. If it is surrounded by the n number of charges, if it is surrounded by the n number of charges like Q2, Q3, Q4, so either the resultant force on the Q1 it is given by F1 plus F2 plus F3, so on up to Fn, right? So this is the superposition principle in case of the electrostatics. So waves ಅಲ್ಲಿ ಯಾವ ರೀತಿಯಾಗಿ superposition principle ಬರುತ್ತೆ? Superposition principle ಅಂದ್ರೆ ಏನು according to the wave optics? So see here, according to the superposition principle, when two or more wave motions traveling through a medium superimpose on one another. So what is the meaning of this? That is wave motion, or you know that the wave motion we show it in this manner, right? So ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, according to superposition principle, what they are saying, that is, if there are two waves, if there are two waves traveling in the same direction, traveling in the same direction, they superimpose on one another. So ಅದೇನಾಗತ್ತೆ ಅಂತಂದ್ರೆ they superimpose on one another, and this is giving a new wave. This is giving out the new wave in which the resultant displacement is due to the individual wave. So idrade en resultant displacement irutte, that is the due to individual wave. So antandre, for example, ನೀವು compare ಮಾಡಿ. Okay, so for charges and this one you can compare here. So charges ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತೀವಿ, that is one charges surrounded by n number of charges or 2-3 charges, ಯಾವ ರೀತಿ ಬೇಕಾದ್ರೂ ಹೇಳ್ಬೋದು. So resultant force ಏನಿರತ್ತೆ ಇದೆಲ್ಲ ಚಾರ್ಜ್ ಇಂದ, so that is given by the individual charges. That is given by the individual charges forces. Similarly, in case of the wave also they are saying same here. That is, it is a new wave. Illen hosa wave form ಆಗಿರುತ್ತೆ. Other the displacement ಏನ್ ನಾವು calculate ಮಾಡ್ತೀವಿ, that displacement is due individual wave. So that is due to y1 plus y2 plus y3 plus and so on plus yn. This is due to individual wave ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ಬೋದು. So here, as you know that displacement is a vector quantity, so ಅದನ್ನ ಏನ್ ಮಾಡೋಣ symbol in the present ಮಾಡೋಣ. Yes. So here according to superposition principle, the displacement of the resultant wave what we are getting, that is due to the individual waves at that instant. At that instant, due to the individual wave, this is giving you the superposition principle. Yes, everyone, is it clear what superposition principle? Yes. Is it clear on what is superposition principle in the wave optics? Okay. So again, you don't have the derivation. So ಆ ರೀತಿಯಾಗಿರುವಂತ waves ಗೆ resultant intensity formula already ನಾವು ನೋಡಿದ್ವಿ. So same formula we are seeing. That is the resultant average of the total intensity will be. So here you can see I is equal to I1 plus I2 plus 2 root of I1 into I2 into cos pi. So you can see here, so 2 root of, so 2 root of, it is not I1 I2 cos pi, root ಒಳಗಡೆ cos pi illa. So here the under root we have only I1 into I2 and the cos pi is outside of the root. Okay, so ಏನ್ ಮಾಡ್ತೀರಾ ಗಡ್ಬಡಿಯಲ್ಲಿ ನೀವು ಇದು, if you take it inside the root, the sum will go wrong. Understanding? Okay, so the average of this intensity, it is given by I1 plus I2 plus 2 root of I1 into I2 into cos of pi. Okay, so I1 I2 is nothing but the intensity of both the lights. So lane wave irutte, the intensity of both the light is given by I1 I2. But what is cos pi or pi here? Here the pi is nothing but it is the phase difference. Okay, so in the incoherent sources, that is only main. The phase difference iddagene namge enagatte anta andre we are getting this superposition principle is applicable. Okay, so here pi is nothing but it is the phase difference between the two superimposing waves. So here whatever the waves are there, here whatever the waves we are considering, so idru madhyadalli ಏನು phase difference irutte, that phase difference is taken as it is pi. Okay. Yes. So see here the next point. The significance is that the intensity due to two sources of light is not equal to the sum of the intensities due to each of them. So idantu namgadu formula dalle gottagatte ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the it is not, the intensity is not the just the sum of the two waves. ಹೌದಾ? So resultant ನಾವು ಬರೀ addition ಮಾಡಿ ತಗೊಳ್ತಾ ಇಲ್ಲ, we are taking it by taking sum of I1 plus I2 plus 2 root of I1 into I2 into cos of pi. So vectors chapter ಅಲ್ಲಿ ನೀವು ಕಲ್ತಿರ್ತೀರಾ ನೋಡಿ, the resultant is given by, so ಅದರಲ್ಲಿ ಏನು resultant ತಗೊಳ್ತೀವಿ, that resultant is given as a square plus b square plus 2ab into cos of theta. So here the okay, so but here everything is there under the root, but here we don't have under the root. Here it is only I1 I2 plus 2 root of I1 into I2 into cos of pi. Okay, so again here we have the conditions. The condition now study ಮಾಡ್ತೀವಿ. See here the next point. The resultant intensity depends on the relative location of the point from the sources, since changing it changes the phase difference as we go to the other point. Okay, so ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಇದ್ರದ್ದು ಏನು ಇಂಟೆನ್ಸಿಟಿ ನೀವೇನ್ ಫಾರ್ಮುಲಾ ಬರೀತಾ ಇದ್ದೀರಾ, this intensity is depending on the path difference. ಇದು ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ path difference ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. Discussed phase difference, path difference. Okay. Here we have two conditions, the maximum and minimum value of the intensities. So how to calculate the maximum and minimum value of intensity? See, as intensity vary between maximum and minimum values, it is determined by the maximum and minimum values of the cosine function. So intensity okay. So here whatever the maximum and the minimum intensity is there, that is we can determine by using, just a minute, the screen is getting shared. Okay, so see here the formula. Again, the derivation part is not there. So idರಲ್ಲಿ ಒಂದು derivation ಮಾತ್ರ ಬರುತ್ತೆ full lesson ಅಲ್ಲಿ. Yes. So here the maximum intensity is given by the cosine function. So in maths, we will study the cosine and the sine functions. So here directly formula we are using. This is for the maximum intensity. The maximum intensity is given by, it is I1 plus I2 plus, this is we have written already, that is 2 root of I1 into I2. So this one we can also write it as, that is under root of I1 plus under root of I2 its whole square. Because then split ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ, it is like a plus b whole square. So what is a plus b whole square? It is a square plus b square plus 2ab. Right? But here ab value ಏನಿದೆ, a is root of a, b is root of I2. Sorry, a is root of I1, b is root of I2. So after squaring, whatever the root is there, that will go. So now barodenu I1 plus I2 plus 2 root of I1 into I2. So this is for the maximum intensity of the light. So after superimposing, if you are getting the minimum intensity, so minimum intensity we can just balance, and that is given by I1 minus root of I1 minus root of I2 whole square. So if you split it, it is like a minus b whole square. So a minus b whole square is a square plus b square minus 2ab. But ಇಲ್ಲಿ ಯಾಕೆ I square ಅಥವಾ I1 square ಯಾಕೆ ಬರೀತಾ ಇಲ್ಲ ಹೇಳಿ? Because ನಮ್ದು ಇಲ್ಲಿ ab value ಏನಿದೆ, under root it is, right? So if you are doing I1 root of I1 its square ಮತ್ತೆ square root cancel ಆಗುತ್ತೆ. So ಉಳಿಯೋದೇನು, that is only we have the I1, right? So therefore it is I1 plus I2 minus 2 root of I1 into I2, and that is giving me I1 minus I2 its whole square. Yes. So this is regarding the maximum and the minimum intensities, or when the light waves superimpose with each other. Okay. So after this, actually we have the Doppler effect in the textbook, but the Doppler effect, because ಕೆಲವೊಬ್ರು textbook refer ಮಾಡ್ತಾ ಇರ್ತೀರಾ, so discuss ಮಾಡ್ತಾ ಇಲ್ಲ, because according to the new syllabus update, the Doppler effect is deleted. So Doppler effect ಅಲ್ಲಿ red shift, blue shift ಅಂತ ಬರ್ತಿತ್ತು, ಅದು ಕೂಡ delete ಆಗಿದೆ. Okay, so Doppler effect formula is also there, but that also we are not discussing because complete the Doppler effect is deleted. Okay, the next one here, Young's double slit interference experiment. Okay, so here the next phenomena what we are discussing is the Young's double slit experiment. Okay, so here already we have discussed about the reflection, already we have discussed about the refraction of light. So light alli ನಾವು ಕೆಲವೊಂದು phenomena ಅನ್ನ already study ಮಾಡಿದೀವಿ, because so many lessons we have completed till now. So we studied about the reflection phenomena, school ಅಲ್ಲಿ 10th ಅಲ್ಲಿ ಕೂಡ ಕಲಿತೀರಾ. We have studied about the refraction phenomena, emergent ಅಂತ ಕೂಡ ಕಲಿತೀರಾ. Then next we have studied the dispersion of the light. So dispersion of the light we have studied, spectrum we have studied, then photoelectric effect we have studied regarding the light. Yes, photoelectric effect. So these are the different phenomena where we can understand regarding the light. So in this chapter we are studying about the three phenomena. That is, the first one is the interference of light. The first phenomena is what? Interference of light. Then we have the diffraction of the light and the polarization. So first one is the interference of light. So first let us discuss about the interference of light. So in this also some parts it is deleted, like a Young's double slit experiment, the main derivation that is deleted. So we have only left from that. Okay, so first here we will discuss what do you mean by the interference of the light. Okay, so what is interference of light? Here the interference of light is defined as, interference of light ಅನ್ನು ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, how you study about the reflection, refraction, ಇದೇನಾಗಿದೆ, this is one phenomena. ಅದೇ ರೀತಿಯಾಗಿ interference ಅನ್ನೋದು ಕೂಡ ಒಂದು phenomena ಆಗಿದೆ. Okay, so this is also naturally takes place here. In the interference phenomena, the redistribution of the light energy takes place. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, the redistribution of light energy due to superposition of two or more light waves takes place. Okay. So here in the previous case, what we have studied, the intensity is how the principle of superposition we have discussed. So superposition principle mele yeah, interference phenomena define agathe, because in the superposition principle what we have discussed, that is we have the two waves. So the two waves are getting superimposed here. Yes. So this is nothing but the principle of superposition. Hauda? So Young's double slit ಏನ್ ಹೇಳುತ್ತೆ ನೋಡಿ, due to superposition or the superimposition of the two or more light waves, the redistribution of the energy takes place. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, when there is a superimposition of the two light waves, when there is a superimposition of the two light waves, here we are getting one new wave. So the ಎರಡು wave superimpose ಆಗಿ ನಮ್ಗೆ ಏನ್ ಕೊಡ್ತಾ ಇದೆ, this is giving out the new wave. So obviously whatever the new wave is having, this is having the different energy. ಹೌದಾ? Because ಇಲ್ಲಿ new wave form ಆಗ್ತಾ ಇದೆ, that is having the energy of this wave also, this wave also. So this phenomena is called as what? Interference of light. So what is interference of light here, students? Interference of light is nothing but it is the redistribution of the light energy. So here due to the different frequencies, due to different energy, due to the phase difference, illenagatte new wave form aagta ide. So whatever the new wave you are getting, that is having the energy of these two waves. So idanne proper statement yav reetiya define ಮಾಡಬಹುದು ಅಂತಂದ್ರೆ, the redistribution of light energy due to superposition of the two or more light wave is called as interference of light. Yes. So till now how you remember? ಅಂದ್ರೆ ನಿಮಗೆ ಯಾವಾಗ ಬೇಕಾದ್ರೂ ಕೇಳಿದ್ರು refraction phenomena ನೀವು ಹೇಳ್ಬೋದು. ಹೌದಾ? Because that many times it is repeated. So in the 10th class also you have studied this, and again in the previous chapter also you have studied this, and the sound chapter. So 9th standard sound ಅಲ್ಲಿ ಕೂಡ reflection of the sound ಅಂತ ಕೂಡ ಕಲಿತೀರಾ. ಹೌದಾ? So whatever refraction, how you remember clearly, interference also you remember clearly. This is one of the important phenomena for the light. So ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ, the redistribution of the light energy takes place due to the superposition of the two or more light wave is called as what? That is interference of light. Yes. Is it clear everyone? What is interference of light? Any doubt is there in the yes, understood or no? Interference of light. So if you are not understood in the message, you can tell. Yes. Okay. So again, in the interference of light, we can study the types of interference. So what are the different types of the interference of light? That is interference of the light. Only two types are there. Here you have the constructive interference and the destructive interference. So we need to see the definition. I'll formula mark. So what is constructive interference? What is constructive interference and what is destructive interference? Okay. So how you can define? So as the term is saying, so term e ಹೇಳ್ತಾ ಇದೆ constructive, destructive. So destructive anta andre, here you can see that here what is happening in the destructive interference, it is the opposition of the constructive interference. So let us define that. How to define the first one, constructive interference. So first, before that, one more definition. I don't know you remember this or not. Okay, suppose now ಇದನ್ನ wave ಅಂತ consider ಮಾಡಿದ್ರೆ, anybody knows what is this part is called as, what is this part is called as? In the sound topic also we study this, and in the light topic also we study this. So wave alli ಎರಡು point ಬರುತ್ತೆ. This is one point, this is one point. What are these 2 points are called as? ಯಾರಿಗಾದ್ರೂ ಗೊತ್ತಿದ್ಯಾ what is the parts are called as? The highest positive point ಅಥವಾ highest negative point ಇದು ಯಾವ್ದು ಇದು ಇರ್ಬೋದು ಅಥವಾ ನೆಗೆಟಿವ್ ಪಾಯಿಂಟ್ ಕೂಡ ಇರ್ಬೋದು ಆಯ್ತಾ. ಸೊ this is also there, this is also there. ಇದು ಯಾವ್ದಿದ್ರು ನಡೆಯುತ್ತೆ. Here in these two cases, so this is called as ಇದೇನಿಲ್ಲಿ highest positive point ಇದೆ ಮತ್ತೆ ಇಲ್ಲೇನ್ lowest negative highest negative point ಇದೆ. This is called as what? Crest ಅಂತ ಹೇಳ್ತಾರೆ. This is called as what? Crest. So ಈ ಪಾರ್ಟಿಗೆ crest ಅಂತ ಹೇಳ್ತೀವಿ. And here what we have at the mid ಇಲ್ಲಿ ನಾವು ನೋಡ್ತಾ ಇದೀವಿ. This is called as trough. This is called as what? Trough. Yes. So ಇದು ಗೊತ್ತಿದ್ರೆ ಅಷ್ಟೇ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. What is constructive interference? What is destructive interference? Yes. Is it clear what is crest and what is trough? So see here whatever the interference of light, wave ಏನ್ ನೋಡ್ತಾ ಇದೀವಿ ಇದೇನ್ okay. So be from the beginning I'll explain you. ಇಲ್ಲಿಂದ ವೇವ್ ಮೋಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಇದೇನಾಗತ್ತೆ, it will go to some maximum point and from there it will return back and again it will go to negative side maximum point, again it will return back. So same way here also happens, again it will return back. ಇದೇ ರೀತಿಯಾಗಿ ಇದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇದನ್ನ ನಾವ್ ಏನಂತ ಹೇಳ್ತೀವಿ, ದಿಸ್ ಇಸ್ ವೇವ್. ಓಕೆ, ಸೊ ಇಲ್ಲೇನ್ ಪೀಕ್ಸ್ ತೋರಿಸ್ತಾ ಇದ್ದೀರಾ, ಇಲ್ಲೇನ್ ಹೈಯೆಸ್ಟ್ ಪಾಯಿಂಟ್ಸ್ ತೋರಿಸ್ತಾ ಇದ್ದೀರಾ, ದೀಸ್ ಹೈಯೆಸ್ಟ್ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಕ್ರೆಸ್ಟ್. ಇದನ್ನ ಕ್ರೆಸ್ಟ್ ಅಂತ ಹೇಳ್ತಾರೆ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಕ್ರೆಸ್ಟ್ and here this is called as the trough. This is called as trough and this is also called as trough. Okay, yes. So now let us come for the definition of the constructive interference and the destructive interference. So for the constructive interference, how we can define it? When the crest of one wave falls on the crest of the other wave. So for example, ನೀವು ಇದು wave ಅನ್ನ ನೀವು consider ಮಾಡಿದ್ರೆ, so this is one wave. So suppose here the ಮತ್ತೊಂದು wave ಏನಿರುತ್ತೆ, the crest of one wave falls on the crest of the other, or through of one wave falls on the trough of the other wave, their displacement gets added. So ಇದನ್ನ ಎರಡು ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು. I'll change the color so that you can understand. So ಇದೊಂದು ವೇವ್ ಆಯ್ತಾ. ಓಕೆ, ಸೊ ಮತ್ತೊಂದು ವೇವ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಸೊ ಮತ್ತೊಂದು ವೇವ್ ಕ್ರೆಸ್ಟ್ ಮತ್ತೆ ಫಸ್ಟ್ ವೇವ್ ಕ್ರೆಸ್ಟ್, both the crests are overlapping. Okay, or you say that the normal word, when the crest of one wave falls on the crest of the other wave, ಈ ರೀತಿಯಾಗಿರ್ಬೋದು, ಬಟ್ ಕ್ರೆಸ್ಟ್ ಜಸ್ಟ್ ಮ್ಯಾಚ್ ಆಗ್ತಾ ಇರುತ್ತೆ. If the crest of one wave and the crest of the other wave falls on each other, or ಮತ್ತೊಂದು ರೀತಿಯಾಗಿ ಏನ್ ಹೇಳ್ತೀರಾ, if the trough of one wave if the trough of one wave and falls on the trough of the other wave, so this is known as constructive interference. ಇದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, constructive interference ಅಂತ ಹೇಳ್ತೀವಿ ಸ್ಟೂಡೆಂಟ್ಸ್. So what we are saying in the constructive interference, the crest of one wave and the crest of one other wave, or the trough of one wave and the trough of the other wave falls on each other, their displacement gets added. Iದ್ರ displacement ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ, their displacements get added. This is known as what? Constructive interference. This is known as constructive interference. Okay, so for the constructive interference, the wave, the intensity of the wave, the intensity of the resultant wave is maximum. The intensity of the resultant wave is maximum for the constructive interference. So already ನೀವೀಗೇನ್ ನೋಡಿದ್ರಿ, the maximum intensities and the minimum intensity ನೀವೀಗಷ್ಟೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ರಿ, ಹೌದಾ? ಸೊ maximum intensity ನಮ್ಗೆ ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, we will get it when we have the constructive interference. ನಮ್ಮ ಹತ್ರ ಯಾವಾಗ constructive interference ಇರುತ್ತೆ, we will get the, that is maximum intensities. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So in that case, the crest or the trough on each other, we are getting the constructive interference, just giving you the maximum intensity. Giving you the maximum intensity. Understood? So similarly, destructive interference. So destructive interference ಅಲ್ಲಿ ಒಂದೇನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬಹುದು, the wave minimum intensity ಇರುತ್ತೆ. The intensity will be what? It is minimum. So ಹಾಗಾದ್ರೆ ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತೀರಾ? If the crest of one wave, the crest of one wave falls on the trough of the other wave, or the trough of a wave falls on the crest of the other wave, this is called disturbance. Okay. So constructive interference, the crest and the trough falls on the same with maximum intensity. Destructive interference, crest and trough are falling each other. That is called as the destructive interference. Okay. Yes. So see. So in the constructive wave, that is interference, here we have already we have studied about the this one, that is regarding incoherent and the coherent sources. So here what we are seeing, the constructive interference and the destructive interference, phase difference ಮತ್ತೆ path difference formula ಇದೆ. So as I told you, theory of this is deleted. Theory part delete ಆಗಿದೆ. ಹಾಗಾಗಿ ಬರೀ ಫಾರ್ಮುಲಾ ಮಾತ್ರ ನಾವು ನೋಡ್ತಾ ಇದ್ದೀವಿ. For the constructive interference, the phase difference is given by, for the constructive interference, the phase difference is given by delta pi is equal to 2 pi n. Delta pi is equal to 2 pi n. This is phase difference. ಆಯ್ತಾ? Difference 2 pi n ಅಂತ ಬರುತ್ತೆ. Here whatever the n value is there, ಇದು 0, 1, 2, 3, so on up to. Okay, so n is a integer. N is a integer. So ಇದು ಯಾವ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ actually ಆ derivation ಅಲ್ಲಿ ಇತ್ತು, but that is not required. So phase difference is given by delta pi is equal to 2 pi n, and the path difference is given by delta x is equal to n into lambda. Delta x is equal to n into lambda, again is an integer. N is an integer. Okay, so this is path difference. This is the path difference. So for the path difference, we have delta x is equal to n into lambda. Again, n is taking the values 0, 1, 2, 3, so on. Yes, so this is for the constructive interference. Similarly, we have for the destructive interference. We have it for the destructive interference. So for the destructive interference, the delta pi is equal to, it is 2n minus 1 into pi. This is phase difference. Idu phase difference agate. And the path difference is given by, and the path difference is given by 2n minus 1 into lambda divided by 2. This is for the path difference. So phase difference 2n minus 1 into pi, path difference 2n minus 1 into lambda by 2. Albari n into lambda anta ittu, but minus 1 and lambda divided by 2. Yes, see. Okay, any doubt is there, students? The interference phenomena, the superposition principle. Understood the interference phenomena, superposition principle. Okay, yes. So the next one is the diffraction and again intensity distribution is there, that we will discuss in the next class. So another 2 class I require, we will complete. Okay, so tomorrow we will meet, students. Bye.